Okay, let's start. Today, we are going to talk about efficient neural networks for edge devices, and the focus of this conference is to have the big picture about the other trends against ChatGPT. So this is interesting nowadays. If you see some robots like Tesla robot that published some weeks ago, and we need different kinds of AI for robotics and real-time applications. So, well, okay, that's me as Dr. Bayer was my mentor, my professor in the university. I'm a computer engineer from UABC, from Baja California, Tijuana. And also I study at IPN, also in TJ, a master and a PhD in artificial intelligence in general. And nowadays I'm working in ITJ as a data science manager. It's a research and development department using basically data and combining research and industry for deliver some different solutions. And these are some of the tools that I like and I use every day with different tools. So let's begin with the agenda. In this workshop, I want to introduce to you the devices and efficient AI, also talking about tiny machine learning and efficient neural networks in general, and the new AI revolution in robotics and the future trends. As we can see here in these figures, we have a different perspectives. For example, in this one, we have the meaning of the machine learning, in this case, a neural network we want to put in a processor. So nowadays, we have maybe a lot of resources in cloud infrastructure, servers, etc. But it's important to see other kind of applications that doesn't have that kind of the hardware resources. It's like a constraint, right? And that is why we have this other figure here. In industrial and Internet of Things, we have a different kind of devices that doesn't have a server infrastructure, cloud infrastructure. For example, also drones, autonomous vehicles, etc. We need different kind of solutions with different hardware constraints, and that's why it's important. Actually, Microsoft, if you search this model, P53 SLM, is a large level model, an LM, but a small and optimized cost-effective model in order to achieve this kind of goals we are talking about right now. And that's interesting because Microsoft is investing also in this kind of new solutions. Well, why this is important in general in business and in the market? We have a different investments, talking about a lot of money here, also 2,000 billion of dollars. So if you see in the future, have an investment and more investment in artificial intelligence in general. Actually, if you search, do some Google search, you can notice that if I'm wrong, in 2018, some professors told that we need that all students, not only in engineering, need to learn something about artificial intelligence. Let's do some example. If I'm someone in financial and more in business and administration, we need to maybe implement or use this kind of technologies. But for that, sometimes we need an expert, right? So this is important because having a general knowledge of this, we can create different solutions, as we can see here, have a big impact in general in the market. So for most, specifically in edge computing, we need a different kind of investment, similar to the other one, but less one. And is also growing through the years, the perspective, the vision of this, talking about billions. And this is important because nowadays we are visualizing that ChatGPT and LMs, generative AI, impact in the world. So that's interesting because is we saw 2 years or 3 years ago we didn't use this kind of technology, and nowadays is actually some people says I don't Google anything. I use ChatGPT to Google that. So this is important because we have different industrial revolution, right? You agree with me? And five uh, five dot industrial revolution, we have a robot collaboration with different systems. As we can saw, nowadays Tesla, we have different autonomous driving vehicles, also robots, and we need to automatize this process. If we see some years ago, this is going to evolving from electricity to computers and to the application, robotics, etc. And nowadays we want to have some human robots or some robots to automatize collaboration and create smart cities and Internet of Things. I know maybe I love Mexico, but maybe the infrastructure here is not the prepared between the difference with other continents, also other countries, etc. But we need to invest in research and industry for this in order to get this kind of different evolutions in the market. It's important. So, well, here we have the big picture, why efficient AI matters. Let's do some example because someone wanted to say, well, but we have the cloud. Why we need tiny machine learning in a way in a chip? If I can send that information to the cloud, then process and then return that. Let's put an example. Imagine you are using some, I don't know, like a smartwatch or something, too sensitive data, and you don't want to send to the cloud for privacy. So how can we process that information? In some on-device learning, we need a different kind. For example, Alexa actually connects to the cloud and is sharing some kind of information with the company, right? So in other kind of sensitive data, we don't want that. Actually, we have a different kind of examples, but this one is, for me, clear that in some cases we need to have some privacy. And that's why it's important to have an embedded solution, an edge device solution. And the other one, as we can see here what's the name? In this image, in this figure, we have a lot of resources, more resources, RAM and storage. But in the other way, it's most difficult to have more resources for the processor, for microcontrollers. And that is an impact, as we can see in pandemic of COVID, that have a problem in silicon solutions so that these microcontrollers, this hardware have some problems with the materials, etc. And this is interesting because if we search about the cloud requires a lot of hardware resources, a lot in energy, actually have a bad impact in the, what is the name, in the ecosystem, in the environment, because we are consuming and affecting the environment in general, but we are interested in the solution, not in the maybe in the planet, right? Are different perspective. Let's continue with the next one. Defining the edge devices. Well, as we mentioned before, we have different levels from cloud data centers that have thousands of data centers, depends on the region, and we have different nodes, different servers that have that processing that is the point between cloud and the edge devices. But in edge devices, actually, we have billions or edge devices, and these ones are because are different kind of solutions, from mobiles to some robot, to autonomous vehicle, etc., smartwatch. And if you can notice here, we have a lot of information in the edge devices, and that's why these companies, when we are talking about later, have some interest in order generate that data and collect that data from the edge devices locally in order to don't share that information with everybody. As you can see, and as you can notice, in this kind of market, the business, we need to keep that. So, well, continue with this analogy. We're going to introduce to efficient AI for edge devices in general. And what is efficient AI in general? We have a different solutions. In this case, I'm going to focus in neural networks as the title of this conference. And we need to optimize and reduce the recurses, talking about memory, talking about the time, and talking about the deployment. Because we know that some solution is maybe very good in the cloud and infrastructure, but when we need to do some deployed and mobile embedded and real-time applications, we need to some challenges here. So in this figure, we can notice that we have two point of views from large models, in this case, large neural networks, and the other one is small neural networks. In some ways, we have a problem because the model is not doesn't have a lot of parameters in order to solve the problem, and the other one we have more parameters. We can solve the problem with a better accuracy, but it's too computationally expensive, and we need to put that in some device, and sometimes it's a constraint with memory and also the speed time, etc. So, well, for this, we have different principles of efficient AI. As we can see in the right side, we have some figures here about talking about the relation between the model size and the GPU memory. As we can see here, the model size is growing a lot. So in the case of NVIDIA GPUs, actually doesn't achieve the same time of growing in comparison of the model size. Actually, this one is from 2022. So nowadays we have a more billion of parameters of other models like GPT-4, etc., GPT-5, and we have in this other figure here, this max refers to memory access, accumulated access, and that's mean the memory that we need and the models need to access and compute. For example, we have a different model with different parameters, different for these ones, with 60 million of parameters that have some access, and it's growing. So in the left side, we have three important points. We need to reduce the model size, because if we reduce the model size, we require less memory and less time. And that minimizes the computation actually of the model, and that's mean power efficiency. That's power efficiency. If we think about the electricity, we require less electricity and less cost. And that's why it's important this. Well, let's talking about other kind of names that is these kind of technologies. In some ones have edge AI devices. In this one, tiny machine learning, you can search it in Google and find different interesting actually tools nowadays that I'm going to share you today. Well, introduction to tiny machine learning. Tiny machine learning actually is this, as you can see in these different figures. We have some neural network or some solution. We optimize that and put in some microcontroller. And that microcontroller have a different functionality like this in this figure. Imagine you have some sensor, and that sensor is collecting information. You are processing it with some AI, and you are sending that information in a local network with different IT devices. So depends on the perspective, but in summary, as we can see here in this figure, we have machine learning, and we have on the other side embedded systems. If we try to join these ones, we obtain tiny machine learning, focuses in embedded systems, in general, and we have these points here. Tiny machine learning on microcontrollers, and also operates in milli or microwatts. That consumes a lot of less resources for opposite of the cloud, and are suitably for devices with a strict energy budget, as we mentioned before. So this one is fun. I didn't this figure. I found it in the Google. If you search tiny machine learning, it's talking about it's the next AI revolution, and it's going to eat the nowadays LLM. We are talking about this. We can also discussing this interested figure and the other trends in a final of this conference. Well, why is the next AI revolution? Maybe someone they wait. Nowadays, GPTs and llamas are the AI revolution. I agree with you. That's true. But if we have the other perspective, imagine if we have some infrastructure, Internet of Things, nowadays is big data. In some time, we need to evolve that. We need to do more efficient way to solve the problems, to reduce what? Reduce the resources, in other ways, the electricity, and the other part, the money you invest in that. So it's feasible and actually makes sense that why this one is going to be the next AI revolution in general. So in this, we have a different perspective. Actually, this one too. Uh, I follow these two pages. You can find them, searches, sorry, with Tiny Machine Learning Foundation that is for Asia in general, have a foundation with researchers, industry, community that work with this kind of solutions. And other one that is very interesting, MIT have a laboratory that the Professor Han, who is a researcher from MIT that is also a data scientist, principal, if I'm not wrong, in NVIDIA, have different startups, different companies that NVIDIA use in order to create this kind of efficient AI solutions. So if we check this figure here, we have different terms, right? We have efficient machine learning, and that efficient machine learning we have from the cloud, that actually we can do that also for cloud infrastructure. But we have the other side for edge devices, and specifically for tiny machine learning devices, most focused for microcontrollers. So in these 3 points, we can notice that we need some energy efficient. That is, it's a challenge too, that is required in general for the different companies. Also, decentralized intelligence. I mean, sometimes when we are working with this kind of technologies, we have a data center, a cluster, etc. But in this case, with only one device, not a lot of devices, we can process something, and don't depend on the other ones. That's why is this perspective. And the other one, the accessible and scalable. This is interesting because imagine if you have I don't know, different drones working with this technology and communicate. This drone told you, okay, I saw this information. I'm going to send you to the drone too and tell you what I see and process the information. And it was a kind of collaboration. In my other case, for autonomous driving. Imagine in a car, we are going to, I don't know, some market, and that vehicles autonomous have I are a lot of traffic here in this path, and send that information to the other autonomous driving, and the other autonomous driving change their decision, tell okay, the other autonomous other car told me that we in this path we have some traffic, and this kind of solution we can do that in different kind of devices, and that's interesting, and that's why it's scalable. Well, example of tiny machine learning applications in general. Actually, if you have a smartwatch, you actually have this kind of technology because you are having some kind of monitoring, and if you have some kind of prediction, an estimation, have some kind of AI. And this one have a low power, low latency, lightweight, and actually different solutions. So in general, nowadays, maybe we didn't see this technology, but if we can notice in all the world have different devices that uses different AI solutions for what is the name, for some hardware resources constraints. That actually is the meaning of these technologies. Well, actually, if we do some research, it's these different models. In my PhD, I work with these 3 models, and these 3 models have different perspectives. I mean, someone is to mobile devices in order to reduce the computations and the spice. the space, sorry. And the other ones is in order to maintain the accuracy, maintain the results without, what is the name? Without more parameters, more model size. And actually other ones like EfficientNet is for smaller models and faster training, because we have here different problems. One of them are we depend sometimes, many times, from the cloud. So this kind of technology also try to say we don't want to depend on the cloud, because we need a lot of money to invest in the cloud, and that's why this different kind of architecture and solution uh, go from research and industry in general. So this is a book, you can search it, Efficient Processing Deep Neural Networks, from different researchers. And no, in this talk, we are going to, in this conference, sorry, in this conference, we are going to talk about the different techniques that exist many years ago in random growth. So model compression techniques, we have different ways in the deep neural networks, in neural networks in general, in order to reduce that resources. For example, pruning, removing unnecessary parameters. Imagine you have some problem and you say, well, I am going to put more parameters to the model because the model is going to solve better the problem. And maybe you are true. But when the model achieves some results, all these connections here are not strictly necessary. And this kind of technique try to reduce the unnecessary connection, unnecessary parameters, as we mentioned here, and that optimize the process, reduce the resources. The other one is a quantization, reducing the model precision. As we can know in software, in general, working with computers, we're working with bits, right? So we have a different precisions, fault precisions, if we reduce the number of bits in order to reduce the size, in this case, of the model, we achieve that require a lot of resources, and actually maybe we have less time. But that actually also reduce the accuracy to solving the problem. As you can see, we need here a trade-off in order to solve the problem and actually check if the model what is the name? If the model have the correct constraints about that device for the deployment. And the other ones are the knowledge distillation that we are going to explain later, that maybe we can use a bigger model, for example, ChatGPT, and that ChatGPT teach to the smaller model. That's one kind of a technique. It's interesting when we can solve. This other picture is a other way of the data that we can see. As you can see here, we have a cat, and that cat have some resolution, a number of colors. And if we put only 16 color, we can notice that we are not losing a lot of information, and we can represent the same original image and original characteristics. And this one is analogous as we are explaining about the quantization information or quantization the model, about precision of that. Well, let's continue with this. Well, what is MobileNet? MobileNet, as we talking about before, we have a lightweight model. It's a CNN. This CNN models is for image classification in general, object detection, as we can see here. And also the name is for mobile. That's why it is the name. You have this picture here. And try to do efficient for real time, result limited applications, etc. So this is one of the models we talking about before. The other one is SqueezeNet. SqueezeNet is a other kind of model that achieves some accuracy with 50% fewer parameters than other one. Imagine you have some solution with 90% and create other model solving the same problem, achieving the same results, but with a lot of parameters matter, less, sorry. And that's why it's important in this kind of efficient models. Actually, it's ideal for deployment and resource control devices. And this is some example that how much FPS photographs per second using like in video games. For example, we can process an image in real time. And that's why it's also this one important. And the last one, EfficientNet and the model scaling, we have here these two figures for the evolution of the parameters in EfficientNet. And as you can see here, well, maybe, well, I hope we have a good accuracy talking about some problem, and we have a balance. A balance meaning that we have a model that have some parameters, and we got the results. And this one also can be scalable in order to optimize for some solution, for some embedded application. And that's why this one is also too important. Don't be afraid. These are the architecture in general, the operations, and you can Google it actually if efficient it and check the different operations that use this model is too similar to the other architecture. And well, application and case studies. We are going to see the different applications nowadays. As we mentioned before, robotics and AI in general already exists. Well, this one is a new one, a very cool new one. On Elon Musk, Tesla, and the company. We have this one from Boston Dynamics, and this one, if I'm wrong, from NVIDIA. Actually, Amazon has different robots that are using for these different problems, and we are going to ask, well, how can we do that? Well, actually, with some real-time low power processing and efficient AI, because for this, we need to reduce the energy cost and the resources for robots, right? So that's why this kind of applications is going to have some impact in robotics. Well, other case of study that actually I did in my master and my PhD is autonomous driving. As we can see here, this kind of models, we have a different kind of detections, object recognition, etc., and solve different problems like the Teslas, right? Well, this one, as we know, if I put a model with a lot of energy cost, imagine your Tesla every 50 minutes to need to recharge that. It's a problem, right? That's why this have an interest of that kind of companies. Well, actually, as we mentioned before about the health monitoring devices, this one have a different information. Maybe in sometimes you're going to say me, Miguel, but I'm not checking this is not AI prediction. This is a monitoring process. Maybe you are right, but depends of the watcher because someone's trying to give you some advices or some trending about your data. The data is collecting these devices, and that have some kind of intelligence. So this is some of the perspectives in health monitoring. Amazing have very have a big impact also actually an investment in this kind of solutions. Well, we are going to talk about efficient items for edge devices. And as we mentioned before about the problem in general, nowadays I'm going to put this analogy interesting from MIT researchers. When we born, we have some synapses in our brain. So when we are going to born adult in a time, we are losing that synapses, but actually we are optimizing our process, right? If I have 5 years of experience doing something, I'm reducing the information, the synapses, and the things that I need. And actually, with the time, some neurons dies. You can search on that, and it's similar to these ones here. So it's the same. That's why this is kind of techniques that imitates the human behavioral and reduce the power in general. The other one is the quantization in practice. As we mentioned before, we have this figure here. Imagine you have a lot of bits in order to a lot of precision. Is we can remember that when we are working with numbers and in the computer, we have some specific precision. So if we are reducing that precision, imagine from the zeros, the number, we are losing that information, that precision. And if we use this half precision, reduce the resources of the model, but actually also reduce the accuracy. And in the case of quantization, we have a continuous signal, and that signal we are quantifying that part. As we can see in the other way, we are passing from continuous to discrete values, different discrete values, in order to doesn't lose all the information, but maybe the more representative information in order to solve the problem. and is similar to this CAD image we saw before, okay? And the last one, but not the least important, actually I want to mention that it exists different techniques, but this one is the three more common, I believe. And we have a smaller student that learns from a larger teacher. And actually, in the real world, that happened. For example, Dr. Ryan, my mentor, in the class, we learn a lot from their experience, for his experience. And with that, we are the students, right? We are trying to optimize and improve that information that teacher is sharing to us, the students. So it's a similar. We are imitating that kind of process. In this case, we are trying to use large models that solve the problem, and solving that problem teaches also to the student model that have less parameters, because we have a teacher that knows all the answers. And we have here different examples with pre-trained models, or other models that train from scratch, etc. But this one is useful too, because we are deploying lightweight models with less resources. Well, it's going to recapitulate this, the next AI revolution, robotics and autonomous systems. The future of edge AI in robotics in general, we can see different kind of proposals. Maybe in some type futuristic, but if you are searching in different countries, have this kind of solution in different stations. For example, these one are from Amazon. And if you don't know about the packages, Amazon is trying to optimize the process using robots in order to move in a very efficient way the administration and the package moment. So actually, these are robots, and maybe needs to some maybe have some resources constraint, right? In industrial production, actually, also needs a different robots for different kind of problems, and the other ones are drones, right? So in summary, as we can see, we have different necessities in the market and industry in general with robotics, and the robotics have some constraints with energy and resources in general. Well, also Tesla and HCI autonomous system, as we can see here in the right, this robot, imagine if this robot do everything right. I don't know, I didn't see the video already, or the videos about this robot, but it's interesting. And if I want to have this robot, for example, maybe have we need a lot of money for that robot, also for that Tesla. We need to have in that robot maybe some AI, efficient AI, because imagine the same problem as I mentioned before. If this model requires a lot of resources, maybe it's not going to be efficient in the term of the time is working. The time having enough energy to achieve the different tasks. And that's the pains of different challenges, right? Well, why efficient AI matters for sustainability? I'm switching and passing a little more faster in order to achieve the time. Energy reconstruction and efficient AI in general, we had different problems if we search about the energy. So we have this example here in this figure, the general fossil fuels. And in the future, we want more sustainable energy from the sun, from the air, etc., in order to create new energy. So with AI, we can do minimize that errors in order to minimize the consumption, talking about energy in general, and is more sustainable in a what is the name, in the large path. Because imagine if we are consuming more water, more energy, we are more people, the humanity is growing. In some time, is not going to be enough the resources we have, because it's not infinite resources, right? So that's why this is important also. Well, in general, the environmental impact of AI, as we can see here, the evolution of global electricity demand by region is growing with the years, right? And the other side, we have the tiny machine learning applications that have different gaps with the what requires for the different solutions. That's why reducing the power and cost is important in order to reduce the global electricity demand, Obviously, we know that depends on different factors, not only for AI in general or for these kind of devices, but we are trying to contribute with different kind of solutions to achieve this. Well, we are in the final of this conference. Here we have some hype cycles for artificial intelligence in 2023. If we see here in this point, we saw what generative AI. And Gartner is a company that try to see the trends in the future and told 1 year ago, actually, also, 5 years generative AI is going to impact. But ChatGPT nowadays is a big impact, right? And we have here HCI that actually a year ago mentioned in less than 2 years. So I mean, nowadays we have the impact of generative AI, and if we have a range of 5 to 10 years, and actually happen right now, and here actually I want to mention this is an estimation. Depends on different factors as pandemic and COVID change a lot of things. So it's an estimation, but it's going to happen in some time. That's why this kind of trends is important. In the morning, some days ago, I searched about machine learning in Google Trends. You can search it too, and we have some interest is growing in 2024. So as you can see here in the regions, maybe are not US, but have some interest, but Asia in other sectors have that investment in these kind of technologies. In summary, we have these key trends in AI, and this opportunity because we have a lot of information, and nowadays we have data is the new oil. Because if we saw and search big data, we know that data is everywhere, and we want that data in order to have a lot of insights and information about data analysis of that and different solutions, right? And if we saw the market of talking about HI and market, we have another perspective that have a very big impact, talking about billions. So it's interesting. I believe maybe take a check about that. And not all is that it's cool. Obviously, these have a different challenges nowadays. That's why we didn't see robots everywhere. So we have a different challenge here. But in summary, with this figure, we have some problems in trying to search that trade-off, talking about low power consumption, ultra low latency, also the capability of the model to solve the problem. Imagine if we have a very, very good solution issues in order to recognize some big issue, right? And we are maybe fear about that. I'm not going to use that Tesla because I'm not sure that it's going to do good at task. And this kind of solution, we need to do more research, more investment in this in order to solve it, as we can see in ChatGPT and other technologies. Well, I don't know if Dr. Reyes will have time for this is a 5 minutes video talking about in summary that I share with the audience. We have time to see it, or I finish here.
Yeah, you can play the video.
Okay. Well, okay. You are listening to the video or not? Are you listening to the video?
Not hear the audio.
Okay, I don't know how to do this. Oh my God, I don't know how to, well, select speaker. Ah, this one, right? Select the speaker, Microsoft Teams, yeah, this one, okay. Sorry, with the connection. Okay. Some connection, issue connection, sorry. Let me check if, what happened. Maybe I'm going to open the video on YouTube. I don't know. Well, maybe I can share you the video in the in the Meet. I don't know. Maybe it's my connection. Not already. Sorry.
Sí, Mike, creo que
I don't know what
tiene
happened here.
problemas de conectividad allá de su lado, porque ratito
I'm going to share you with you.
no vi.
What is chat? Sorry about the video. I'm going to share you in the chat. I believe for me is out of some issues with the connection. Let me. I want to put the speaker in order to hear you. Oh my God. Well, actually, only to share the references. You want the presentation? I can share you. And sorry about the video. I send you to the chat. I hope you can see it. Also, I can share you the auto rangers and maybe put in the audience. I don't know. Maybe I have some connection issue. I don't know. I'm not sure. But it's all for me. And thank you, everybody.
Localizaron el video acá, bueno, tratar de transmitirlo de este lado, a ver si se escucha.
Okay. Yeah, it's from minute 6. Talking about the examples of edge devices and the investment in the different companies.
It's 67 degrees Fahrenheit with clear skies and sun.
The smart speaker is always listening, but in a limited way. A simple model is running on the smart speaker's processor. It only responds to a particular word or phrase, which is Alexa in this case. Everything else is ignored. Once it hears that, it begins to stream raw audio to a cloud server, which performs inference using a much larger and more complex machine learning model. This model performs intent analysis to figure out what the person is asking for. It looks up that information and sends the response back to the speaker, which then plays it in audio form. The smaller model running locally on the speaker allows it to respond to a user in real time without having to waste bandwidth constantly streaming audio. The larger cloud model, on the other hand, performs the much more complex task of figuring out what the user is asking for. Many wearables, like smartwatches and rings, can be used to track sleep and exercise activities. For complex models, cloud computing might be required, but many are simple enough that they can run on the device itself or an attached smartphone. In other cases, the model can run entirely locally on the end device. For example, automated optical inspection systems look for defects in manufacturing processes. Smart cameras can be used to identify issues with packaging or pallet loading. Even without cameras, sensor data like electrical current, vibration, and sound is useful for monitoring machinery and moving parts or potential problems. Such data can be mixed together and analyzed for anomalies. Autonomous vehicles and robots can't assume a stable internet connection, so most of the processing must be done on the vehicle itself. While Ericsson predicts there will be 7.3 billion smartphones in the world by 2025, IDC estimates there will be some 41.6 billion IoT devices producing 200 million terabytes per day. That's a lot of data to transmit through the network if you have to rely on cloud computing. By pushing AI and compute closer to the devices that produce the data, we can free up much of that bandwidth. At the recent Data and Analytics Summit, Gartner estimated that in 2021, about 10% of all data processed by deep neural networks occurred in endpoint devices on the edge. They predicted that this will increase to 55% by 2025, which demonstrates how the edge AI market is exploding. In addition to the growing demand in software advancements, the hardware industry is also stepping up. Gartner predicts that AI accelerator chip revenue will reach $137 billion by 2027, growing by a 5-year compound annual growth rate of 26.5%. All this points to a booming AI industry, and edge AI will continue to play an important role by augmenting existing IoT and end-user devices. Edge AI helps by limiting bandwidth, lowering latency, reducing energy consumption, enhancing device reliability, and ensuring data privacy. I'm excited to see what unique challenges you tackle with Edge AI. Next up, we will dive into some technical details about the different types of Edge AI processors and how to choose the best one for your needs.
Bien,
Thank you, Dr. Reyes. Thank you for sharing the video.
ok, estamos todavía tiempo, tenemos 3 minutos para si la audiencia quiere hacer una pregunta. Los que están en distancia o los que están presentes. Angélica Escoda o alguno está presente virtual. ¿No? ¿Los presentes? Ok, yo tengo 2 preguntas rapiditas, Mike. La primera es, pues primero lo felicito por el nivel de inglés que está manejando, la verdad es sorprendente. Y quisiera que les diera una recomendación a estos chicos que están aquí presentes, de cómo, si ese nivel ya lo tenía cuando terminó la carrera de ingeniería o lo logró en el posgrado.
Es un buen punto, profe. ¿Lo digo en español o en inglés?
Para que los anime.
¿Mande?
En español, para que los anime.
Ok, está bien. De hecho, cuando salí de la carrera, pues tenía cierto nivel en inglés, ¿no? No es el que tengo ahorita. Y ya cuando entré al posgrado, pues sí nos piden un nivel más de inglés, ¿no? O sea, para participar en conferencias, etcétera. Pero pues ya empecé a invertirle yo al inglés. Mi recomendación sería, digo, a los muchachos en general, tal vez uno no le da importancia cuando está en la carrera, ¿no? Y se concentra tal vez en la programación, pero créanme que te abre mucho las puertas, inclusive pues es el lenguaje, digamos, más utilizado en el mundo, ¿no? Número uno. Mi consejo sería que lo practiquen, que le pierdan miedo a si se expresan mal, el acento, etcétera, es irle perdiendo el miedo. Y es pura práctica al final. Así fue como lo logré yo, ¿no? Fue puro ir a practicar, digamos, algunos cursos ahí que tomé en la maestría e yendo a conferencias y perdiendo el miedo, ¿no? Y ya mientras lo vas haciendo diario, te vas acostumbrando. Entonces, ese sería mi consejo, o sea, que vean videos en inglés, que platiquen con gente en inglés y lo traten de practicar lo más, ¿cómo se dice? Lo más diario posible, ¿no? En la medida, ¿no? Sería mi consejo.
Vale, por otro lado, pues, al estar escuchando su plática, me di cuenta de cómo en el pasado yo había escuchado el uso de las redes neuronales y algunos otros métodos de inteligencia artificial. Y en el área de electrónica y ese tipo de cosas, los había escuchado sí ser utilizados. Pero, por ejemplo, ahorita cuando habló del tema de consumo de energía, me estaba imaginando si esos algoritmos se programan y el software embebido que va en esos dispositivos, eso es parte de la programación ya fue optimizada o los algoritmos propios con los que trabaja son los que llevan la inteligencia artificial a nivel de redes neuronales y algunas otras técnicas.
Ok, esa es una excelente pregunta, profe. Básicamente, hay como diferentes formas como de hacerlo. Por ejemplo, ¿no? Tal vez una programación más directa al embebido, como dice, ¿no? Inclusive hay algunas herramientas, ¿no? Como MicroPython. Pero básicamente lo que se puede hacer es como, me regreso, es aquí hay un slide donde viene esa parte. En resumen, nosotros podemos hacer esa solución, por ejemplo, acá, ¿no? ¿No? Este es de TensorFlow. Es digamos, un framework, ¿no? Que le llaman TensorFlow Lite. nosotros podemos hacer esa solución en nuestro servidor en la nube o en la máquina que tengamos, ¿no? No necesariamente en el microcontrolador. Y ya que tenemos esa solución, la cargamos, ¿no? La flashamos en este tipo de microcontrolador. Entonces, como menciona, ya se queda como ya hay en memoria y se queda ese programa ahí. Entonces, la importante aquí que yo veo es de que uno como programa, ¿no? O sea, qué tan bueno es uno para programar, digamos, ya sea la red o la solución. La herramienta te va a ayudar, ¿no? A mejorar y reducir los recursos. Pero si uno no programa, un ejemplo, ¿no? Bien las clases, ¿vea? Bien las funciones, las iteraciones, etcétera, pues le vas a cargar más, ¿va? Al microcontrolador y pues aquí no tenemos los recursos, digamos, pues demasiados recursos, ¿no? Suficientes. Entonces va por ahí. No sé si era como lo que me estaba preguntando ahorita.
Sí, sí, la verdad, sí, pues muchas gracias. Bueno, Miguel Ángel, pues, le vamos a dar las gracias. Si nos permite la pantalla por desplegarle su reconocimiento, el cual voy a proceder a leer. Y pues espero que el público se haya entusiasmado, al menos yo sí me llamó mucho la atención esa parte de lo que yo conocía antes de esas técnicas de inteligencia artificial y lo que nos puede usted ahora, pues veo que hay evolución. Entonces, que los demás de la audiencia se entusiasmen y progresen. Ok, entonces pues vamos a leer la constancia que dice: la Red Temática Mexicana de Ingeniería de Software le otorga el reconocimiento al doctor Miguel Ángel López Mundial por haber presentado de manera exitosa la conferencia titulada Vision Neural Network for Asian Devices. En esta 12ª edición de la International Conference in Software Engineering, Research and Innovation, Conexión 2024, la cual está siendo realizada en la Universidad del Mar de 28 de octubre al 1 de noviembre de este año en Puerto Escondido, Oaxaca. Firman al alcance la doctora María Alejandra Meléndez Ortiz, chef local, y su servidor, el general chef de Conexión 2024, doctor José Reyes Juárez Ramírez. Muchas gracias, doctor Miguel Ángel, y espero que nos veamos pronto en otra participación de usted con nosotros. Muchas gracias.
Claro que sí, doctor Reyes. Muchas gracias a todos por asistir. Que tengan excelente tarde. Hasta luego. Bye bye.
Momento ya la última conferencia, pues quieren un poco y iniciamos.